Hello everyone. In this tutorial we'll cover how to use nRF5 software development kit in conjunction with Visual Studio Code. Okay. So here we have a freshly installed nRF5 SDK. It's version 16. If you have another version, it should not be a problem. So let's go to the examples folder. I will go to the BLE peripheral folder here. I shows a bunch of examples, and I will copy the Blinky example here. All right. So what we will do, we will open now a separate folder here where we will work. So let me call it test, and I will paste the example here. So before we proceed further with Visual Studio Code, let us first run the example in Segger Embedded Studio IDE. So I will go to the PCA 140 folder here and enter this folder. SES stands for Segger Embedded Studio. So here we have the project file, so I will open it. Okay, now if you go to the bottom of the main file, you can see that it already has some logging in here. And the thing about this example is that it uses UART for logging by default. So I would like to use SeggerRTT interface. So what we do, you can edit the SDK config file manually, but I will right click on it and choose CMSIS config wizard here. And so it is easier than editing the text. So I'll go to the nrf log. So if you hover over UART setting, you see that it's already selected. So I will deselect it and select the RTT option. So let me save it and build and debug. So I have nRF52 development kit, the hardware development kit, connected to my computer via USB. So we should be able to see the logs now. And the reason why I prefer to choose this example, the blinking example from BLE peripheral, actually there are two reasons. First reason is that in other examples, not all of them have the required source files for SeggerRTT print functions. And second reason is that this example uses Bluetooth and hence soft device, so it will be handy in future steps. Okay, the file is compiled and let us debug it. Okay, you see the logs are being depicted here. Everything is working as we expect. Okay, so I think we are done with Segger Embedded Studio. I just wanted to show you that everything is working, and all we did, we changed the SDK config file so that it uses SeggerRTT instead of UART. Now that we are finished with dealing with Segger Embedded Studio, so let's do following. So I will go to our folder and right click on our example and open it with Visual Studio Code. Okay. So in Visual Studio Code, you will need two extensions. So let me show the ones that I'm using. So one is the C++ extension, this one, and cortex-debug. Cortex-debug will help in two ways. It will help to show the SeggerRTT logs here in the terminal, and also it will provide the actual debug interface, with the breakpoints and etc. But before going on with the Visual Studio Code interface, I want to show you the logic. So for now we will be just using the console here. So this is our example. So I will enter this folder. So it has one subfolder, so let us enter it as well. Okay, so up to now we have been using the ses folder for Segger. Instead, now we'll be using the armgcc folder. So what armgcc means is a GCC for ARM. So the code that you are typing, that you are writing in your nRF SDK, I mean the code, it will not be executed on your computer, but it will be executed on nRF. And nRF uses ARM processors, so you need a compiler that will translate your code to the ARM machine code. Okay, that's why it's called armgcc. So let's go to the armgcc folder, and here you have a makefile. Okay, so I will just type make, and I get an error. So it says that it cannot find the compiler. So here it cannot find the compiler. So firstly, you need to download the compiler from the ARM website. Okay, but probably after installing it, you will get the same error, and I will show you how to fix it. But just one important nuance is that when you install the compiler, make sure to add it to the path. Okay, so you will have an option to add it to the path, so it will be handy, and I will show you why. So let me check if I have the compiler. Okay, so I will type arm none bgcc, and let's check it version. So you see I have it installed actually, and the version is 10.3.1. okay, so for your SDK to see the GCC, so I will show you how we are going to fix it. So this is the root directory of SDK. I will go to the components folder, toolchain, GCC, and there is a file called makefile window. So let's open it with Notepad. Okay. First thing that you can notice is that the version is different from the one that we use. So mine was 10.3.1. So let me fix it first. So I will make it 10.3.1. And next, so there is a path, the default path provided in this file. So let us compare it with the path that we have. Okay, so I will go to local disk, program files, and this is the GNU ARM folder. Let me enter it, and this is the binary folder to which it should I mean this is the path that SDK wants to see. So let me copy this directory names and paste it here so it is visible. So first of all, I mean these names are completely different. So it's called GNU Tools ARM Embedded, and mine is called GNU ARM Embedded Toolchain. So let me replace it firstly. And second, the version here is 7 blah blah blah, so I will be using the one that I have here. So let me replace it and delete this. Okay, I will save it. We do not need command line anymore, and let's try the make again. Okay, it is working, and we did the we solved the first problem, and now nRF SDK and can see the armgcc compiler. Okay, now that we are finished with makefile, let's see the results. So we have a new folder here, in addition to the two previous files that already existed in the armgcc folder. So it's called build. So let's see the contents of this file, of this folder. So there are a bunch of files. The most important one is this one, the hex file. This is the actual, let's call it executable file that we are gonna put into the nRF microcontroller, okay, and this one with the out extension will be used for debugging, okay. Now there is one minor change that we need to do before proceeding further, so I will do the following. So let's go one folder up, and before we just called make with no targets. Now I will do this. I will make call make SDK config, and this will open the CMSIS config window over here, and you should go to nRF log. So if you remember, previously we enabled RTT and disabled UART. So there is one important thing about RTT logs. So their advantage, I mean, this is according to my knowledge, please correct me if I'm wrong. So the RTT advantage of RTT logs is that you do not need any additional hardware. I mean, your USB cable for flashing the nRF is also handling the RTT logs. Okay, this is the upside, but the downside is that you can, so let's say we have RTT logs enabled. So if you debug the problem, it's okay, it will be working. But if you just do the build and run setup with no debug, the RTT logs are actually going to cause your program to reset infinitely. So since we are not doing debug, we will try to flash the program at the moment. So what I will do is I mean it's already unselected here, and for the UART it's up to you. You can either enable or disable it, okay. So I will call the make again with new config where I disabled SeggerRTT. So I mean this one, this is important, otherwise your application will not work. Now how are we going to actually test if the application works or not? So this is the source file, I mean the main file, okay, and in the main file you can see a macro called device name, and it's called Nordic Blinky. So on your phone you need to download nRF Connect app, okay. I'm using iPhone, so I go to App Store and download nRF Connect. Via this application you just scan for the nearby devices, and you should be able to see a device called Nordic Blinky, okay. So but for us to see it, firstly we need to flash the program into our microcontroller, okay. And as I showed you already, we have the hex file here that we are going to upload. But so how are we going to upload it? There are two ways. One way is using command line interface, and second is with graphical user interface. So let me first show you the graphical user interface, how it's done there. So let me type nRF Connect here. So it is actually it may be confusing, but there are three types of nRF Connect. I mean three meanings of nRF Connect phrase. When we are talking about phones, we talk about the application that you are using for scanning Bluetooth devices, for connecting to them, probably communicating with them, sending some data or reading some data from them, okay. When we talk about computer, there is an nRF Connect application that is here, okay, and it is a superset of various tools. So for this particular purpose, we are going to use the programmer app inside nRF Connect, okay. But there are a bunch of other nice tools. For example, Power Profiler. I'm using it frequently. It's very useful, but it requires additional hardware actually. Okay, and the third one is nRF Connect SDK. So this tutorial is done for nRF5 SDK, right? But there is actually another SDK which is called nRF Connect SDK. So this is the third interpretation of nRF Connect. So okay, now enough of that, and let's go to the programmer. Okay, so what we will do is, firstly we will select our device. I mean, it is connected via USB, and then we need to add the hex file that we made. So I will go to our example. So here, okay, here is the hex file. So let me press open, and I mean, this is actually a nice thing about nRF Connect. You can see how your executable will be stored on the device memory. So this green strip over here is actually the memory footprint of your application. Okay, but if you try to upload it this way, I mean, what we do, we are going to call the erase and write command here. It will not work, and that is because there is no soft device here. So if your application uses Bluetooth, you also need to add soft device. It's like driver for Bluetooth, and you do not have the actual source code in your nRF5 SDK within your application. I mean, in your nRF5 SDK, you just have the interface to communicate with soft device, to request something from soft device, etc. But the actual implementation of soft device is inside here. So let me show you. You go to let's go to the root folder of nRF SDK, components, soft device. You choose the soft device version. I'll choose mine. Go to the hex folder, and this is it. You see the actual hex file. So let me add it, and you see how it sits in a complete different location inside the memory. So there is special memory for your reserved for your soft device here, and it does not intersect with your application code. So I will do erase and write, and on my phone I will go to nRF Connect app, and let's see if I can see the Nordic Blinky. Yep, it's there. So this scheme is working. Next, I will show you how to use command line to achieve the same result. Okay, now let's try to do the same with command line. So you need to download something called nRF command line tools from the Nordic website. After you download it, there will be, it has a lot of stuff there, but the common things that we use are these. So one is called nrf-jproc, okay, and another one is called merge hex. Pardon me, so it's merge hex. Okay, these two tools will be using these two to program our microcontroller. So let's start with nrf-jproc. So you can add -help here to see all available options. Okay, and let me show you the common ones. So for instance, -r resets the microcontroller, -e erase everything on the flash, and you use -program, add a hex file that you would like to upload, and also some or one of these arguments which are mandatory. I mean, you first need to erase old data before writing new. I mean, that's how Flash works. Also, another one is verify. So once you flash your program with a file, you can verify if it is flashed properly. So you add the actual file that you uploaded previously and compare it with the contents of the flash. So let's just try out some of these. So I will do nRF_jproc -e. Remove everything that we did with nRF connect. Now it's empty. Next, let us try to. So I'm in the build folder. This is my hex file. Let's try to program it into the memory. So nRF_jproc -program. I need to specify the program. So this one. This is the program. So and we need to add the mandatory option. So I will do a sector erase. Okay, now after I did it, let's verify if everything went well. So I will do -verify and provide the file for comparison. So it says everything is okay, so good. But the file that we uploaded, I mean, it is not sufficient to work. I explained it already. We also need a soft device. So, but the thing with nRF_jproc, it requires one hex file. Okay, so you need a way to combine soft device with this hex file, generate a single hex file, and pass it to nRF_jproc. And for this purpose, we are using the merge hex tool. Okay. Merge hex tool is more simple. So usually you just have two arguments here. So -m, you specify files, so a.hex and let's say b.hex. These are files that you want to merge, and then you specify with -o flag how the output file will be called. So let me call it c.hex. Okay, so if I created a copy of soft device and put it in the upper directory here, just for easiness, not to look for it for a long time. So I wanted to show you it. You can do the same. So what I will do, I will call merge hex our hex file. Then second file is one directory upper, and this is the name of the file. And let's say I want to call the output something.hex. Okay, it gave me an error because I forgot the pardon me, I forgot the -m flag here. Okay, it's should be cool now, and we have the newly generated file here. So I will do following. Now that we have the file, I will call nRF_jproc so -program. Name of the program is something.hex. I want to chip erase everything before programming it. Then I want to verify if my program is indeed written correctly, and after that I want to reset my hardware. Otherwise, I mean, otherwise you would need to manually reset your hardware for the program to work. So let's try this. Okay, now I will go to my phone, open the nRF Connect app, and let's see. Okay, I have the Nordic Blinky here, so everything went properly. Now that we are finished with learning the basic stuff, now we will try to make our life easier by using features of Visual Studio Code. So let's start. In the makefile, there are few targets that are already available and which we can utilize. So one is called flash. So when you type make flash, it will call the underlying commands here. So as you can see, it is also using nRF5. So it has separate one for flashing soft device, for a whole chip arrays, for editing SDK config, and the default task is for building the project. So what we will do is let's go to terminal and select configure tasks. Choose from template and select others. So it will give you a simple template. So what is it? So let me rename it to something. Let's call it James Bond. And if you go to terminal, run task, so James Bond will appear here. So let me select it, and it will give me a bunch of options in order to get rid of them. So what you do, you add this field. So problem matcher is blank. Okay, now we should not get these options. So let me select James Bond, and it will print hello because that it is the command of this task. Okay, to print hello. Now we should do. We will have the same pattern for our tasks, and we will utilize makefile instead of writing custom scripts using nRF5. It will make life easier. So let me actually let's create the first task. So first task would be build, okay, to compile our project. So, and I mean, what do we do here in the console? So we go to the armgcc folder and call make, right? So I want the same to happen in this task. So I will just write the plain make here. Okay, let's run task, build, and it will give me error because it cannot find the makefile. So we need to specify the path. So for this purpose, we need to add following field. It's called options, and inside it another field called current working directory. And I will repeat the same directory that we've been working on. So S132 armgcc. So let's try it again. Run task, build. Voila, it's working. Now let's replicate it and create other tasks. So 2, 3, 4, 5. So first one was build. Next one is flash. Let's call it flash application, and it calls make flash. This one would be flash soft device, and it would call make flash soft device. Then we would erase all, and that would call make erase. So let me check if the spelling is correct. So flash soft device, erase, yeah. And the last one is SDK config. So I will call it edit SDK config, and it will be make SDK config. So let's try them. Run task, build, works. Run task, erase all. Beg your pardon. Erasing works. So what else do we have? Let's flash our application. Works. Edit SDK config. Works. And flash soft device. Everything is working. And the good thing about this approach, if you notice, merge hex is not being used here. That's because of this flag, the sector erase flag. So let me run flash application again. So once you have flashed the soft device, okay, so if you remember, soft device is being kept on a special area. its own area on the flash. So when you type flash application, so it will erase the flash, but only the part for the application. So it will not touch the soft device. So you don't need to merge anything. Okay. So this is a good approach. And I think that's all about mostly. I'm almost finished about the tasks. With few exceptions, there are a couple of improvements that you can do. So for the build task, since we are using it often, we can make it a default task. So instead of going here and choosing it here every time, you can do it with your keyboard. So I will add a group field, and it will fill it for me automatically. So it says that it is a default task. So what you do, you press Ctrl, Shift, and B on your keyboard, and it will by default call this task. Okay, whichever is default. And second one, I mean, it is not required for this particular example, but just for your reference. So you can add something called depends on. So it will invoke, before calling this task, it will invoke other tasks if those are prerequisites. So let's let's try it with erase. Okay, so I will run task called build. Oh, okay, that was my mistake. So let me call it erase as well. Run task build. So it first, before building, you see it calls make erase, and after it is finished, then it is starting the actual task. So it may be useful for you in future, but for this example, we do not need it, so I will delete it. Yeah, and that's all about the tasks. Okay, now let's deal with the debug stuff. So make sure you have the cortex-debug extension. Okay, so let's go to run, add configuration, cortex-debug. So it will add a template for launch JSON with the cortex-debug stuff. So this file will handle the debug settings. So we have 6 fields already filled here, and this one is important. It's called executable. So in our build folder, in addition to the hex file, I told you that this file without extension will be used for the debugging. So let me copy its name, and we should provide the path to this file. So path is PCA140. The file name. Okay. Now, in addition to these 6 fields, we also need to add other fields. There are plenty of them, so instead of typing them one by one, I will just copy and paste them, and later I will share the files with you. Okay, so these were the initial 6 fields, and so let's see what we have later after that. So device name, it is mandatory, but I guess you can call it whatever you want. Interface could be JTAG or SWD, so I've been using SWD so far. Pre-launch task, so let me comment it for this moment, and I will explain it later. Server path, if you go to program files, so we've been working with this folder, but there is also called folder called Segger. Inside it you have a JLink folder, which have various executable files, and the executable of interest for us is this one, JLink GTB server client. So you need to provide the correct path to this executable. Then you provide the path for your compiler. Okay. SVD file, I will show you later what it does. So this field here is required to avoid errors, and this field, it allows you to see RTT SeggerRTT logs here in Visual Studio Code without opening any additional program. Okay, now few more things that we need to do. Let's enable SeggerRTT logs first. So I will go run a task to edit SDK config. In the nRF log, I guess I already did it. So you see I enabled SeggerRTT logs and disabled UART. So let's save it. And very important thing, you should go to makefile, and here in the optimization flags part, you should remove this one, or maybe do replace -03 with -00. But if you keep it -03, it will create a mess during debug. So this -03 optimization, it optimizes out a lot of stuff, and debug becomes a mess. It actually took me a couple of days to figure out that the problem was originating from this flag here. So this one is important. So we changed the makefile, we changed the SDK config. By the way, I mean it's just for debug. Now we need to rebuild our project. So I will build. So while it is being built, I will want it to. So let me show you. 1 second. Okay, so this is our main program, and we have a log here. So we expect to see this log in Visual Studio Code, and apart from that, what we want is to be able to put breakpoints, see local variables, step into functions, and etc., as you would normally expect from a debugger. And for this purpose, we will click run and start debugging. So let us first finish the build process with a new project. It should be finished soon. Okay, it's linking and done. So I will run task to let's erase everything for any case. I will flash soft device because it was erased as well, and then I'll flash our application. Okay, now let's give it a try. I will click start debugging. Okay, here we are. So for this time, let me just click continue so the program executes. I will go to terminal, and here I have a window for called RTT channel 0, and you see I have the logs here. Ignore the fact that these are repeated. I think it is sometimes during debug or flashing. I also noticed it. The program resets. It's okay. So what else can we do? So let's debug again. I will put a breakpoint here. So let's continue. Step into this function. See the local variables. You see we have the error codes and stuff. And the most important thing is, so let me grab my phone and check. So let us just continue. I will grab my phone and check if the Nordic Blinky Bluetooth device is visible to nRF Connect app, and if it's working, we are done with debug. So just one moment. Okay, sorry, my phone was far from the table. I guess I'm not the best tutorial maker, so let's connect to nRF Connect. Go to nRF Connect. Yes, I have the Blinky here, Nordic Blinky here, so it is working. I think we are done with most important stuff. So I mean, I don't pretend to be expert in this stuff. So this is just the things that will help you to get started. In the video description, you can find links to various other implementations for Visual Studio Code. So you see, normally when you create a project, you have a project and you want it to work in Visual Studio Code, there will be a new folder in your project. It will be called Visual Studio Code, and it will have various JSON files. So we created tasks.json, launch.json. So tasks.json, you already know what it is. Launch.json is for the debugging. And there are also a couple of things that you can add, and you will see those in the examples. For instance, so in my main C, I mean, I cannot see the definition, the source file. I cannot see the headers of these types functions. So I need some way to include it. So I guess this stuff is being done in CPP projects JSON. So you will be able to see the implementations from the links. And I forgot to show you what was the use of, yes, there are a couple of things that I forgot to mention. So in the debug, so let it start. So you see there is a field here, it's called cortex peripherals. You can see all the peripherals on your microcontroller, and you can see it thanks to this line, the SVD file. Okay, so I wanted to mention this, and this one I was going to cover. So I mean, we have a problem with current setup. So let's say I add a for loop here. I mean, I print something else here. Okay, let's print okay, something. I will not get creative. And if you I mean, normally what you expect, I mean, what we usually do, you do some modifications in your code, start debugging, right? And would like to see the new output of your program. So if I press continue, I do not see the newly generated stuff here because I'm debugging the old program. So what you actually can do is you can do following. You add a pre-launch task. Okay, so in our task I have a task called flash application. Okay, so I'll do following. I will write flash application. So whenever I would like to debug, I'll make sure that I will flash the latest application. Okay, and for the flash application, I mean, what flash application does, it's so let me go to console. It will go to the build folder and see the latest hex file and just flash it into the memory. So what I can do here, I can add a dependent task. So I will write build here. So this will what happen whenever I start a debug. Before that, I'll need to flash the application. Okay, and the flash application task, before flashing it, it will rebuild the project. So this way, your debug should be up to date. So let's give it a try. You see, I'm recompiling the main file. So this is a build task. Then I'm flashing the newly generated file to my microcontroller. And now hopefully the debug will start and I should be able to see this nonsense. Okay, Let's go to console. Yes, I'm seeing this nonsense. That's pretty good. Okay, that's it. And thank you for watching the video.